Hello, my Calc students. Today we talk about two very important tests. It's called ratio and root test. This is section 9.6 from your book. And start study. We have this kind of theorem. Let's you have series with non-zero terms for any n. And then we have this situation. Series is, and start with 1 to infinity, converges absolutely. When when limit absolute value fraction n plus 1 terms over n terms and approach to infinity less than 1. Second, series is the series diverges when this limit absolute value n plus 1 terms over n terms and approach to infinity greater than 1 or equal infinity. This means or your sequence diverges. Okay? And third one. Question. Okay, less than 1 converges, greater than 1 diverges, but what happened if limit equal 1? It means ratio test is inconclusive. This means use something different. Test is when limit equal 1 and approach to infinity. Doing some examples. Series is 2 power n over n factorial n from here we have 0 to infinity. Remember please, 0 factorial is definition equal 1. This means 0 factorial is non-zero. Okay. Try use ratio test and we have limit 2 to the power n plus 1 over n plus 1 factorial over 2 to the power n over n factorial and approach to infinity. Ratio test is very good test if you have some factorial in your series because you can easily simplify and approach to infinity and you have 2n plus 1 n factorial over 2 to the n plus 1 factorial. Start simplifying, you have this one cancelled, it's here, n factorial cancelled, here you have n. This means you have limit and approach to infinity, you have 2 over n plus 1. What this means is 0. 0 is less than 1, and our series is converges absolutely. Doing second example. What happens if you have series n to the power n over n factorial? Okay, what we have here? Limit n approach to infinity, n plus 1 power n plus 1 over n plus 1 factorial divided by n power n over n factorial equal limit factorial. Okay, we have n factorial over n to the power n. Start simplifying. What we have here? N factorial, and here is cancel it. We have n plus 1, but n plus 1 over n plus 1, n plus 1 power over n plus 1, this you can cancel. And this means finally we have, here is limit n approach to infinity. Limit, our numerical is n plus 1 n power, our determinant is n power, n approach to infinity. I will write a little bit different way. I have limit, here is n plus 1 over n, and this one I rewrite like 1 plus 1 over n power. How you remember, I hope you remember, when you study L'Hopital rules, we prove this limit is equal e. But this mean is greater than 1, and mean is our series is diverges. Now we study one more test. It's called root test. And theorem tell us if you have series, okay, series an and 1 to infinity converges when limit nth root from absolute value an and approach to infinity less than 1. Second, the series an and from 1 to infinity diverges when limit nth root from absolute value an and approach to infinity greater than 1 or infinity, and root test we cannot use, or root test does not work if this limit is equal 1. When limit in absolute value an equal 1. Okay, doing a couple of examples. Example A. And you have series e to the power 2n over n to the power n, and start with 1 to infinity. Try use root test. It will be limit nth root from n terms this is n. Use property of power. We have limit n approach to infinity e to the square over n. Constant divided by infinity, it will be 0. This means our series is converges absolutely. No, I don't write absolutely here because this is series with positive terms. This means converges absolutely, it's same. Okay. Looking more examples, but before I start, see carefully in page 632. This is page when we have table with all tests what we used before. These tests you need to remember and what kind of situation you can use this test and what kind of solution you have after using this test. Checking your page 632 is very important. Okay. And now doing something similar with your homework. Question number 28 from your book. What we have here is series n factorial over n to the power n. And from 1 to infinity. I think here it's better use ratio test, and we have limit an plus 1 term over an term and approach to infinity. This is our ratio test, and our situation we have n plus 1 factorial over n plus 1 power n plus 1 and approach to infinity, and this one will be divide by an. This means multiply by flipping and factorial. Start simplifying what we have here. N factorial, and this is factorial this is n plus 1, here is plus 1 then, and we have limit n to the power n over n plus 1 power n and approach to infinity. Or we have limit n over n plus 1 power n and approach to infinity. How you remember is from L'Hopital rule, when we have variable in the base and variable in the power. Okay, let's go. This is some limit is equal a, and then take it natural log. Natural log, it will be limit natural log n over n plus 1 n power and approach to infinity, or is mean limit n natural log n over n plus 1 and approach to infinity. Because I want to use L'Hopital rule and I'm switched for x and rewrite like fraction, and will be limit natural log x over x plus 1 divided by 1 over x approach to infinity. Make my life a little bit easier. I'm use property of logarithm, but before we start using, if you plug in infinity, you have 0 over 0. This means use L'Hopital rule is correctly. Okay, I have ln x minus ln x plus 1 over x, and now use L'Hopital rule. We have limit 1 over x minus 1 over x plus 1 minus 1 over x squared. Oops. X approach to infinity. Here we have it. We have, make it same denominator. First fraction we have x plus 1 minus x over x times x plus 1, and all of them multiplied by negative x squared. Okay, here cancel it, and this limit is equal negative 1. Natural log a equal negative 1. This means a equal e to the negative 1 power 1 over e, who is less than 1. This means our series, remember what kind of series we're solving. It will be series n factorial n to the power n converges. One more time, I'm not tell converges absolutely, because this means this series with all positive terms converges absolutely, and converges the same. Okay, doing one more example is number 20. What we have here, we have series when we have 5 power n over n to the 4th power, and start with 1 to infinity. Okay, use same ratio test. You have limit n approach to infinity 5n plus 1 power n plus 1 fourth multiplied by n fourth over 5n. Simplify, we have this kind of, and it's mean I have 5 limit n to the 4th over n plus 1 to the 4th. But this limit is equal 1. 5 times 1, it will be 5. Greater than 1. This means my series is diverges. Okay. Doing more examples. Here's 2 examples for root test. Number 42. We have series negative 3n over 2n plus 1 2n plus 1. All of this is n power. Oh, sorry, 3n power. That is not important. Okay, no, this is important. 3n power n for 1 to infinity. Okay. Use root test. It means nth root from absolute value an's, n approach to infinity. Here we have limit nth root from 3n over 2n plus 1 power 3 n, and from n approach to infinity. Simplify if use root property. We have 3n over 2n plus 1 in only third degree. Our base approach to 3 halves. This means 3 halves cube is 27 over 8, greater than 1, and series is diverges. One more example, number 48. I try to show you more example when you will be easy for solving homework. ln n over n power n, and from 1 to infinity. What we have here, root test tell us limit n's n approach to infinity, n's root from ln n over n, or it will be limit ln n over n approach to infinity. Okay, here if you plug in infinity, you have infinity over infinity. This means here you can use L'Hopital rule, but remember we need go backwards function here, limit ln x over x approach to infinity. It will be limit 1 over x over 1 x approach to infinity equal 0. This means our series and start with 1 to infinity converges. Now I'm showing you solving couple of examples from your section when we can use different tests. It's every time looking what test is more comfortable for each question. For example, number 52. What we have here? You have series 100 divided by n and start with 1 to infinity. First, use property of series. This means if you multiply each term for same number, you can take this number out. You have 1 over n, and from 1 to infinity. This time you have harmonic series. Harmonic series. And this means the series is diverges, because harmonic series is diverges. Number 54. What kind of series you have here? Series and start with 1 to infinity, 2 pi over 3 and n power. This is geometric series. Because you have constant base and power is n. Okay, geometric series with r equal 2 pi over 3. 2 pi over 3 is something similar with 2, equivalent with 2. This means greater than 1, and series is diverges. Okay. Next one, 56. You have series n over 2n squared plus 1 and start with 1 to infinity. What kind of test we use here? I think we use limit comparison test and build new series. This means limit comparison test, and I take a new series equal 1 over n. Remember, limit comparison test and comparison test, you need build second series, and you know about second series is diverges or converges this series is. This is harmonic series and this is diverges series. Okay, checking our limit n over 2n squared plus 1 divided by 1 over n. Approach to infinity, it will be limit n squared to n squared plus 1 and approach to infinity. This limit is 1/2. Limit is constant. This means our series is diverges to n over 2n squared plus 1 to infinity, diverges. Solving next one, 58. You see all these three examples we solving use three different tests. Let's go here. We have series 10 over 3 square root n cube and start with 1 to infinity. First use property of series, we take out coefficient, and third here we have 1 over n, and power n I write this way, 3/2 and start with 1 to infinity. This is exactly p series, and p equal 3/2. Greater than 1, this means series is converges. And solving number 62. Number 62. Here we have alternating series and natural log n, and start with 2 to infinity. Because you have alternating series, first we checking maybe this series is converges. Absolutely, this means I take it series 1 over n ln n. For this kind of series, I think is our integral test is work very well. Okay, we have dx, this means x natural log x, and border 2 to infinity. I think it's t substitution here is ln x, let's go, it's t, dx over x, it will be dt, and here we have integral dt over t with ln 2 to infinity. Here it will be ln t from ln 2 to infinity, and we know it will be diverges. Because this integral is diverges, our series with absolute value, our first series, it will be diverges, or our series is not converges absolutely, but it can be converges conditionally. This means first we checking what happened with limit 1 over n ln n, n approach to infinity. Here we have 1 over infinity, this means 0. Okay, great. First is work. Second, we need checking a n plus 1 terms less than a n terms. It means 1 over n plus 1 ln n plus 1 less or equal 1 over n ln ln n. It means n plus 1 times ln n plus 1 greatest or equal n ln n. Or it will be n plus 1 over n ln. It's true because ln is ln x, y equal ln x, is increase function. This means n plus 1 greatest than ln n plus n plus 1 over n is greater than 1. This means our inequality is right. And we prove our series negative 1 to the n ln n converges condition. I think that's it for what I'm planning for giving this section. Okay, doing homework, and remember, right now you know all tests when we use for checking our series as converges or diverges. Now you're solving your problem is found correct test what you can use for your situation and then solving. It's no problem, I think. Okay, if you have any question, ask me and write email. Okay, it's it.